In this lesson, we're going to look at solutions and solubility curves. So if we think back to solutions, solutions are made up of two different parts. They're made up of the liquid that does the dissolving, so the solvent, and then of the solute which gets dissolved in the solvent. So together, the solute and the solvent make up the solution. And we can see here at the atomic level, so we've got sodium chloride salt surrounded by molecules of water. And in time, what is going to happen is that sodium chloride is going to split into sodium and chlorine ions and be surrounded by water. And eventually, we will have all of the sodium and chlorine split into those ions and mixed all throughout that solution. So if we take a closer look at that, the sodium and chlorine, as they split off, we call that dissociating. So the sodium chloride dissociates, which means it separates into sodium and chlorine ions. And if you recall from Unit 1, we talked about the polar nature of water. So the electrons between the hydrogen and oxygen are not equally shared. They are pulled closer to the oxygen because it's more electronegative, so it has a stronger pull on electrons, leaving this negative pole or slightly negative charge around the oxygen end, and then a positive pole or slightly positive around the hydrogen ends. And so that is what is allowing for this dissociation or this dissolving in water. So you can see that chlorine is surrounded by the hydrogen ends of water, which is the positive pole or the slightly positive charges, and the sodium cation or the positively charged sodium is surrounded by the negative poles of the water. So sodium chloride is going to dissociate into sodium cations and chloride anions here. So solubility, what is that? That is the maximum amount of a solute that can dissolve in a given amount of solvent and at a specific temperature. So at different temperatures, a different amount of a substance can dissolve. So if I take a look here at a particular temperature at 20 degrees Celsius, if I have 100 milliliters of water, I have different amounts of different compounds that can dissolve. So the maximum amount of sodium chloride that can dissolve in 100 mils of water at 20 degrees Celsius is 35.9 grams. So that I would say is soluble. That is a good amount of sodium chloride that can dissolve in there. Calcium hydroxide, and we can see as we look at the picture the difference in amounts. So calcium hydroxide can dissolve 0.183 grams of it in 100 mils of water at 20 degrees Celsius, and calcium carbonate can only dissolve 0.005 grams or 5 milligrams within 100 mils. And so we would say that that is insoluble. So a small amount does dissolve. Insoluble doesn't mean there's no dissolving happening. It just means it's a very, very small amount. And we will look at in more depth at those insoluble compounds in 4U in equilibrium. Okay, so a few other keywords we need to look at. So if a solution is saturated, it means it has the maximum amount of solute dissolved at that temperature. So it cannot dissolve any more solute. We can add more solute, but it will not dissolve in there. If it is unsaturated, that means that it does not have the maximum amount of solute dissolved, which means if we added more, it would still dissolve. And if something is supersaturated, so this is where if you added more solute to a saturated solution, no more would dissolve, and so it's going to just be a precipitate, so a solid within that solution that isn't dissolved. So a supersaturated solution has more than the maximum dissolvable amount, and then some of it is going to be a precipitate or a solid that is not dissolved. So we can use solubility curves to help us identify whether something is saturated, unsaturated, or supersaturated. If it's supersaturated, we can calculate the amount of the precipitate there is. So once the full amount is dissolved, how much extra is there left over that wouldn't be dissolved. And you can see that for different substances, we have different amounts of solubility. So how many grams per 100 grams of water that would dissolve, and it's different at different temperatures. So cesium sulfite here is the only one that decreases solubility as we increase the temperature here, and then it seems to stay steady. Sodium chloride has a very slight increase in its solubility, and then we have other ones that have quite a steep incline in their increase in solubility. So it just depends on the substance. So if, for example, for potassium nitrate, I said that I had 50 grams of potassium nitrate. If my temperature is at 20 degrees Celsius, potassium nitrate is over here. So at 20 degrees Celsius, it looks like about 25 grams is the maximum amount that can dissolve. So if I had 50 grams, that would be a super saturated solution. 25 grams would dissolve, and I would have another 25 grams that would be a precipitate that wouldn't be able to dissolve. So the other question I could be asked here about this is, at what temperature would 50 grams be fully dissolved, or at what temperature would it be a saturated solution? And so for that, I'm going to go along the potassium nitrate curve and see when I hit 50, which is over here. And that looks like it's at about maybe 38 and a half degrees Celsius. So I would need to increase temperature by about 18 and a half degrees Celsius to get to the point where potassium nitrate is a saturated solution. Anything above that would leave me with an unsaturated solution. So once I go beyond that 50, if 50 grams is how much I have, now I have an unsaturated solution there. And then I can also compare different substances. So I could ask at 50 degrees Celsius, which substance has the lowest solubility or the least solubility. So here, the lowest one would be cesium sulfite. I could ask at 40 degrees Celsius, which one has the highest solubility. So there I'm going to go and look for which one crosses the 40 degrees at the highest point. And that would be sodium nitrate with about maybe 94 and a half grams of sodium nitrate per 100 grams of water that can dissolve.